Welcome back to the first PUC topic. So let us consider the classification of elements. Classification of elements as metals, non-metals and metalloids. So based on the characteristics of the elements, we classify them as metals, non-metals and metalloids. Now to understand that one, first let us see the periodic table. In this periodic table, in this particular table, the elements which are shown with the blue color, they are all metals. Those elements which are shown with the light green color, they are metalloids. And yellow elements are indicated for the non-metals. Yellow color is used for the non-metals. That means when we classify these elements into the metals, non-metals and metalloids, just observe that for the extreme left, even up to the right side, most of the elements in the periodic table belong to that metals. To classify the element as a metal, we consider most of these metals with respect to their characteristics. Most of the metals are solids with high melting point and boiling point. There may be one or two exceptions. For example, mercury is a liquid. It is not a solid. And some elements like calcium and tellurium, they have very low melting point. Except these few, most of the metals have got high melting point and high boiling point. And most of these metals are very good conductors of heat and electricity. And most of the metals are malleable, that they can be made into the sheet and they can be stretched into the wires. Except some metals like alkali metals. Alkali metals are very soft. They cannot be made into the sheets. So, we classify these elements as the metals. On the left hand side, of periodic table, the elements are metals. So, to consider these elements as the metals, we have these characteristics. Most of the metals are solids, as I told you, except mercury, which is a liquid in room temperature. And metals have high melting point and boiling point. High melting point and boiling point. Of course, mercury is having very low melting point. That's why it is liquid in nature. And there are some exceptions, except calcium and tellurium, which are having very low melting point and boiling point. And metals are malleable and ductile. Malleability, made into sheets. Stretched into wires. That is called ductility. And most of these metals are good conductors of heat and electricity. Then coming to the non-metals. Non-metals are actually present on the upper right hand side of the periodic table. This is the upper right hand side of the periodic table, including this hydrogen, which is actually placed in the first group. We have discussed already. The position of the hydrogen still not confirmed. The position of the hydrogen is yet to be confirmed because It shows the properties similar to those of alkali metals as well as similar to those of these halogens. How it is possible, we will discuss in the hydrogen chapter. Okay, that's why this hydrogen being a non-metal, it is indicated with the yellow color in this particular table. So, on the top of right hand side of the periodic table, elements are non-metals. Elements are non-metals. So usually the characteristics of these non-metals are, non-metals are generally solids or gases. Solids or gases at room temperature, of course. There is an exception, except bromine, which is actually liquid. At room temperature, bromine is a liquid. Then usually these are non-conductors. Non-conductors of heat and electricity. Heat and electricity. Except graphite, which is an allotrope of the carbon. It is a very good conductor of heat and electricity. Then non-malleable and non-ductile. They cannot be made into wires and sheets. The next topic, next characteristic, low melting point and boiling point. Except except carbon and boron. This is the carbon and boron. Both are having very high melting point and boiling point. There are some exceptions. But generally what we say is, non-metals are generally solids in nature or gases in nature at room temperature, except bromine, which is a liquid. For example, you consider this carbon, phosphorus, these are all solids, selenium, iodine. While when you go for this nitrogen, oxygen, fluorine and all these noble gases, chlorine, etc., hydrogen, they are gases. Bromine is the only liquid. Okay, they are non-malleable, non-ductile, they cannot be made into sheets and wires. They do not have the conductivity of heat and electricity. And usually they are having low melting point and boiling point. That's why they are existing in the gaseous state. So that is how, exception, carbon and boron. Metalloids are the elements present in between the metals and the non-metals. So for example, all these elements which are shown in the green shade in this particular periodic table, boron, silicon, germanium, arsenic, antimony, tellurium, polonium and astatine, they are all metalloids. Okay. These metalloids are present in between the metals and non-metals. Why they are named as the metalloids? Because they show some properties similar to those of metals, some properties similar to those of non-metals. So, metalloids present between metals and non-metals, metals and non-metals in the periodic table. In the periodic table, they show properties similar to metals and non-metals. We can write the example of this boron, silicon, germanium, like that, arsenic, antimony, tellurium, etc. So this is the classification based on the metals, non-metals and metalloids. in your textbook they might have given this periodic table. Just refer to that classification of the elements and go through these elements which are on the extreme left. They are metals. On the extreme right we have non-metals except this hydrogen which is present in the first group, and in between we have the elements which are actually metalloids. Some properties shown by these metalloids are similar to the metals. Some of them are similar to those of non-metals. So this is about the classification of the elements based on their characteristics. In the next video we will see the periodic trends in the properties. When we move from left to the right in the periodic table, say for example, when we move from this first group to the 18th group in the periodic table, it is called as the across the period. When we move from first period to the 7th period, it is called as the down the group. In any particular group, when we move from first to the 7th period, it is called as the down the group. The properties vary. There is a variation in the trend in the variation in the regular trend in the variation in the properties. Those regular trend in the variation in properties are studied under these headings: atomic radius, then ionization energy. Nowadays this word energy is replaced by the enthalpy. Ionization enthalpy. Then we have this electronegativity and electron affinity. This is again named as the electron gain enthalpy. Under this atomic radius, again we have this different types of atomic radii, like the covalent radius, van der Waals radius, and for the various elements we study the positive ion and negative ion. That's why it is cationic and anionic radius. All these, how they vary across the period and down the group, along with the other properties like ionization energy, electronegativity, electron gain enthalpy or electron affinity, valency, that is oxidation state, etc. that we shall see in the next video onwards. Thank you.